All right, good morning and welcome back. One thing I'm noticing right from the start is this is CATS. I need an S right there. I don't know what happened, it's not there. But today, go ahead and we're going to review a little bit from what we've covered so far, chapters 11, chapters 12, chapters 13. We're going to just cover a little bit and talk about some things that we've covered earlier in this quarter and just watch it through to the end. You'll get your points. So STA. If we think about it, this is saying what is the measure, what is the angle STA? So S starts here, T is right there, A is up there. What is this angle over here? Okay, and we know that this is a rectangle. Keyword is rectangle, which means each of these is 90 degrees in the corner. So STA would have to be 90 degrees. Okay, now ACT. So let me get rid of those. A starts here and comes over to C, and then it goes down to T. So we want to know what is this chunk right there. And we know that ACS is 90. Meanwhile, we have 46 already spoken for right here. So we can do 90 minus the 46, and we are left then with 44 degrees. Okay. And from here, if I fill that in, I know this is 44 degrees. All right, let's see. Measure of angle ATC. So ATC, that starts A down to T, up to C. And that wants to know what this is. That is the bigger one. On a rectangle, they are going to be symmetric. And so if we would fold it in half, either hot dog or hamburger style is going to match. That will be 46 as well. Okay. Just like over here, we had 46. This one would be 46, this one would be 46, this one would be 46. Meanwhile, this angle is 44, this one's 44, this one's 44, and this is 44. All right, the final question it asks on this question is, what is CT? So what is the distance from C over to T? What is that diagonal? We know on a rectangle that the diagonals bisect. We also know the diagonals are the same. So if this side is 11, we also have 11 here. The diagonal is 22. 11 plus 11, both diagonals would be the same, and we are done. All right, our next question here says find xy. Xy cuts right here through the middle. That is known as our midline. The reason we can call it a midline of our trapezoid is because, as you can see right here, there are two congruent segments. So ty and uy are the same, which means y has to be the midpoint. Meanwhile, Sx and Vx are the same, which means x is the midpoint. When you connect the two midpoints, you have your midline. To find the midline of your trapezoid, all you have to do is add up your two bases and divide by 2. So 15 plus 6 does give us 21. We divide that by 2, and we will get a distance of 10.5. We don't have a label, so we can just do units. If you weren't sure about that, 10.5, hopefully it makes sense. 10.5 is 4.5 away from 15, 4.5 away from 6. It should always be like that if it's the midline. All right, that was some things from chapter 11. Chapter 12, we moved into triangles. If we look here, our similar triangles, we could know that both the small one, let me highlight it in blue. So the small one right here, and then we have our big one, which I'm highlighting in red. We are able to know they are similar. The reason we know they are similar, up here at the top, they share this angle, so that has to be the same. Okay, and then you can see these marks that tell us these are parallel. Since they're parallel, cut by transversal, I know that both this angle and this angle will be the same, and I know this angle and this angle will be the same. Now, I only need two of those because when I have two angles, AA similarity, that allows me to know that not only, well, the angles are going to be congruent between the two, and then the sides will be proportional. Okay. Now at this point, we can do a couple different things. So the small triangle, we have a 3 over 6 equals, now on the big triangle, the 3 is on the left side. It won't match up with x. It will match up with 3 plus x. Meanwhile, on the right side, the 6 would match up with 6 plus 16, which we know is 22. At this point, we cross multiply. 3 times 22 is 66 equals, now the 6 has to multiply with both the 3 and with the x. Okay, so we get 18 plus 6x. Subtract 18, and we're left with 48 equals 6x. Go ahead, divide by, I got ahead of myself. Divide by 6, and if we divide that 48 by 6, we will get x equals 8. All right. The next one, it says, determine whether these triangles are similar. If so, complete the similarity statement. So right here we see that G and L are congruent. So the only way they can be similar is if those two match up. Which means, since we don't know anything about the other angles, we have to look at these sides. We have to check, does it match up by SAS? Are they similar? So we check 7 over 42. Is this equal to the same proportion as the other one? So 9 over 54. Okay, now, at this point, I don't expect you to do those in your head. We can just do cross multiply. So 7 times 54 equals 378. Meanwhile, 9 times 42 equals 378. So if we cross multiply, we get 378 equal to 378, which means, yes, they are similar. Our reason is going to be by SAS, side angle side similarity theorem. Now, FEG has to be similar to, right here you see there's the symbol for similar. F has to match up with K, E with J, and we already knew G and L went together. Now, what's our scale factor? The scale factor from FEG to KLJ, it gets bigger, so it's going to be positive from small to big. From 7 times 6 gets us to 42, 9 times 6 to 54. So a scale factor of 6 there for us. All right. So it's been a minute since we've done that, but this was chapter 12. Okay. Now the other thing that we talked about, chapter number 13, we talked about SOHCAHTOA. Okay. So if you forgot SOHCAHTOA, remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA. So in our case here, we are solving for x right there. This is the adjacent side. The 32 is our hypotenuse. We have a and h. We want to know a and h. That will be cosine right here. So cosine of 35, because that's how many degrees, all over 1 equals a over h. So x over 32. Okay, at this point we cross multiply. We'll get x equals whatever 32 times cosine of 35 is. Make sure you're in degree mode. If you're using your calculator, go down, change it to degree mode. So, second to quit. 32 times, we said cos, so right here, cos of 35. Close the parenthesis, hit enter, and we get 26.2. All right, the final one then I'm done. So on this one, compared to this x, this is the angle we're solving for. 4 would be adjacent, 10 would be opposite. O and A, we're going to use tangent, TOA. So the tangent of, now this time I don't know what it is, x, equals O over A, 10 over 4. The only way we can do this is to take the inverse. What is the inverse tan of 10 divided by 4? That will tell us what x is. So remember, to get this, you have to be on your calculator, do second tan. That gets us the inverse tan. 10 divided by 4, close the parenthesis, hit enter, and we get 68, if we round, 68.2 degrees as our answer for that angle. Hope you guys have a great break. You can use the rest of the day to work on old Delta math if you aren't caught up. And if you have questions, reach out, and I'll talk to you soon. Bye.